Today, in this session, we will study Introduction to Quadratic Equations. Okay, students, let's start the session. Please look at here. Before going to the topic, what is meant by quadratic polynomial? A polynomial of degree 2 is known as a quadratic polynomial. Right. The general form of quadratic polynomial is ax square plus bx plus c. Right. In this quadratic polynomial where a comma b comma c belonging to real number are, in this quadratic polynomial the coefficient of x square a compulsory not equal to 0. In this quadratic polynomial x is the variable. A real number alpha is called the zero of the quadratic polynomial f of x is equal to ax square plus bx plus c if f of alpha equal to 0. Thus, a zero of quadratic polynomial is that the value of the variable for which the value of polynomial becomes 0. For example, here minus 2 and 4 are the zeros of the quadratic polynomial f of x is equal to x square minus 2x minus 8. Right. So for example, x is equal to minus 2, substitute in this quadratic polynomial, then becomes equal to 0. And also to substitute x is equal to 4 in this quadratic polynomial, right? So this quadratic polynomial becomes 0. So that's why minus 2 and 4 are the roots of this quadratic polynomial. Okay, students, let us discuss some more information related to quadratic equations. Look at here. If f of x is a quadratic polynomial, then f of x is equal to 0 is known as a quadratic equation. The general form of a quadratic equation is right ax square plus bx plus c is equal to 0. This is the general form of a quadratic equation, right? So in this quadratic equation, right, a comma b comma c belonging to real number and also the coefficient of x square a compulsory not equal to 0. Right. So in this quadratic equation, right, if a is equal to 0, then this quadratic equation becomes 0 into x square plus bx plus c equal to 0. This equation becomes bx plus c is equal to 0, right? So this equation is known as linear equation. This equation is known as linear equation. If a is equal to 0 in this quadratic polynomial becomes a linear equation, right? So that's why this is not a quadratic equation. So this is the linear equation. So let us discuss some more information related to quadratic equation. Right. All of you know the standard form of quadratic equation ax square plus bx plus c equal to 0. So in this quadratic equation, right, a, b, c are the constants. In this quadratic equation, a and b and c are the constants and x is the variable. And also, my dear students, in this quadratic equation, if b is equal to 0, to substitute b is equal to 0 in this quadratic equation becomes a into x square, right, plus 0 into x plus c is equal to 0. This expression becomes ax square plus c is equal to 0. So this equation is known as, this expression is known as pure quadratic expression or pure quadratic equation. Pure quadratic equation. Right. And also, my dear students, let us discuss some more information related to quadratic equation. Please look at here. Let us discuss roots of a quadratic equation. F of x equal to x square plus bx plus c equal to 0, where here in this quadratic equation a comma b comma c belonging to R, and also the coefficient of x square a not equal to 0. Right, the definition of roots of quadratic equation. Let's see. The values of the variable satisfying the given quadratic equation are called its roots. Let f of x equal to 0 be a quadratic equation, and x is equal to alpha is said to be roots of the quadratic equation if it satisfies the equation. That means x equal to alpha is a root of f of x equal to 0 if and only if f of alpha equal to 0. Let's see one example here. So for example, my dear students, x square minus 4 equal to 0. This is the quadratic equation. So from this quadratic equation can be written like this: x square is equal to 4. So x is equal to plus or minus 2, right? So here x is equal to 2 and x equal to minus 2. Right? So to substitute, put x equal to 2 in this quadratic equation becomes 2 square minus 4. So that equal to 0, right? Right. So that's why x equal to 2 is the root of this quadratic equation. And also put x equal to minus 2 also in this quadratic equation, right? So minus 2 whole square minus 4 becomes also 0. So here x equal to 2 and x equal to minus 2. So these two values are the roots of this quadratic equation. Are you understand, students? So and then move to some important note points related to roots of quadratic equation. The first note point here: zeros of a quadratic polynomial are same as roots of the corresponding quadratic equation. Degree of a polynomial decides at most number of zeros of a polynomial. Therefore, a quadratic polynomial can have at most two zeros. Hence, a quadratic equation will have at most two roots. For example, right? So 3x square plus 6x plus 4 equal to 0. Right. So in this quadratic equation here the degree is 2. Degree is 2. So that's why this quadratic equation compulsory two roots. Right. Okay, students, let us discuss one important numerical question related to roots of quadratic equation. Right. So if x equal to 3 is one root of the quadratic equation, x square minus 2kx minus 6 equal to 0, then the value of k. So in this numerical question, if x equal to 3 is given, if x equal to 3 is given, is one root of the quadratic equation x square minus 2kx minus 6 is equal to 0, right? So in this quadratic equation, to substitute x equal to 3 instead of x, to replace 3. So 3 square minus 2k into 3 minus 6 is equal to 0, right? So here 3 square is the 9 minus 2k into 3 is the 6k minus 6 equal to 0. Right. In this expression, 9 minus 6 is the 3 minus 6k is equal to 0. So 6k is equal to 3, right? So from this expression, k is equal to 3 by 6. Yes or no, students? So here 3 1 ja, 3 2 ja 6, right? So k is equal to 1 by 2. The value of k here 1 divided by 2. So we can conclude here, right? So here x equal to 3 is one root of this quadratic equation. To substitute x equal to 3 in this quadratic equation, then we get the value of the k is here 1 by 2. Okay, students, let us discuss some important poll questions related to the roots of quadratic equation. Let us discuss some poll questions. Right. So, if x equal to 1 is a common root of the equations ax square plus ax plus 3 equal to 0 and x square plus x plus b equal to 0, then ab is equal to what? Option A 3, option B 3.5, option C 6, option D -3. So in this numerical question, one common root is given from these two quadratic equations. So x is equal to 1 is a common root of these quadratic equations. So this is the equation 1, students, and this is the equation 2. Right, right. So put x is equal to 1 in equation 1. Then a into 1 square plus a into 1 plus 3 is equal to 0. A into 1 square is the a plus a into 1 is the a, right? Plus 3 is equal to 0. A plus a is the 2a plus 3 is equal to 0, right? Yes or no? Right. Very good. Very good. So 2a is equal to -3. So a is equal to -3 by 2. Right. To substitute here x equal to 1 in equation 1, then becomes a equal to -3 by 2. Right. So, and also students, put x equal to 1 in equation 2 also. Then becomes equation 2 becomes, so 1 in 1 square plus 1 plus b is equal to 0, right? 1 square is the 1 plus 1 plus b equal to 0. From this expression, b is equal to -2. Then calculate here ab is equal to. Right, so here a value -3 by 2 into b value -2. So this 2 and this 2 cancel out, minus into minus plus. So here AB is equal to 3. So that's why here option A is the right answer. We can conclude here, put x is equal to 1 in these two quadratic equations. First calculate A value and then next calculate B value. Then multiply those two values. We get final result as 3, my dear students. So option A is the right answer. Right. Okay, students, let us discuss some more information related to quadratic equations. So look at here, students. All of you know, with the help of one formula, easy to calculate roots of quadratic equation, right? So x is equal to minus b plus or minus the square root of b square minus 4ac divided by 2a. Right. So from this expression, from this formula, x is equal to minus b plus or minus the square root of b square minus 4ac, right? So the b square minus 4ac can be treated as d, can be represented by d instead of b square minus 4ac to represented as d divided by 2a. So compare these two, right? So d is equal to b square, d is equal to b square minus 4ac. So here d is the discriminant. D is the discriminant, right? So look at here, students. The main purpose of the discriminant, the main use of the discriminant, with the help of discriminant, easy to identify, easy to calculate the nature of roots. I understand. With the help of discriminant is represented by D. With the help of discriminant, easy to find out, easy to calculate the nature of the roots. Right. So, if in case, my dear students, if discriminant is equal to zero, if capital D means if discriminant is equal to zero, the nature of the roots may be real and equal roots. If D equal to zero, the nature of the roots may be real and equal roots. And also, if discriminant is greater than 0, if discriminant is greater than 0 means positive. If discriminant is positive, or if discriminant is greater than 0, the roots may be real and distinct roots. Real and distinct roots. And also, if discriminant is less than 0, that means negative. If a discriminant is less than 0, that means negative. No real roots. No real roots. Only imaginary roots. Only imaginary roots. If discriminant is less than 0, no real roots, only imaginary roots. Okay, students, let's discuss some more poll questions related to roots of quadratic equation and discriminant. Right, let's see. If x equal to 3 is one root of the quadratic equation, x square minus 2kx minus 6 equal to 0, then the value of k is, already discussed this problem, right? Previous, right? So put x is equal to 3. Put x equal to 3 in this quadratic equation, right? So 3 square minus 2k into 3, right? Minus 6 equal to 0. Just 9 minus 6k minus 6 equal to 0. Right. So here 3 minus 6k is equal to 0. Right. So 3 is equal to 6k. So k is equal to 3 by 6. 3 1 ja 3 2 ja. So k is equal to 1 by 2. So option D is the right answer. Let us discuss some more questions. Students, look at here. Right. The number of real roots of the equation x minus 1 whole square plus x minus 2 whole square plus x minus 3 whole square is equal to 0. Option A 0, option B 2, option C 3, option D 6. So look at here, my dear students. So here the equation is given x minus 1 whole square plus x minus 2 whole square plus x minus 3 whole square is equal to 0. Right. So students, this expression, right, this term can be look like a minus b whole square. Right. This term also can be look like a minus b whole square. Right. This term also can be look like a minus b whole square, right? So simplify here. So x square, right? X square plus 1 square is the 1, minus 2ab means here 2x, right? So plus x minus 2 whole square. So x square plus 4 minus, right, 2ab, right? That means here 4x. Yes or no? Plus x minus 3 whole square means here x square plus 9 minus 6x is equal to 0. Right? Yes or no, students? Yeah, very good, very good. So, right. So from this expression, right, how many students, how many x square terms are there? 3x square terms are there. So 3x square, right? And also how many 2x and also x terms are there? Right? Minus 2x minus 4x is the minus 6x. Right? Minus 6x. Totally here minus 12x. Constant terms here, plus 1 plus 4 is the plus 5, plus 5 plus 9 is the plus 14 is equal to 0. right? So this equation can be look like a quadratic equation. So, right, in this question, right, to find out the number of real roots in this quadratic equation, right, how many real roots are involved, how many real roots are there. So, with the help of discriminant formula, easy to identify the how many roots are involved in this quadratic equation with the help of discriminant formula, right? So, D is equal to, right, D is equal to B square minus 4AC, right? So compare this quadratic equation, the standard form of quadratic equation, right? Ax square plus bx plus c equal to 0, right? Compare these two. So a value 3, right? So b value minus 12 and c value 14. So substitute ABC values in this discriminant formula, right? So D is equal to 3 square minus right. So here B value how much, right, students? So here B square, right? So B value minus 12 whole square. Very good, very good. So minus 4 into A value 3 and C value 14, right? Minus 12 square is the 144, right? Minus 4 into 3 into 14. 4 3 is at 12. 12 into 14 is the 168. Subtract these two, we get D is equal to minus 24. Here D value negative, right? If discriminant value negative, then D is less than 0, right? Yes or no? If D is less than 0, if D is less than 0, no real roots. No real roots. No real roots, right? Only imaginary roots. If discrement is negative, there is no real roots, only imaginary roots. So that's why here option A is the right answer, students. Right. So let us discuss, my dear students, one more question related to, right, quadratic equation. Please look at here. If x square minus of a plus b into x plus ab equal to 0, then the value of x minus a whole square plus x minus b whole square, what? Option A square plus b square. Option B, a plus b whole square. Option C, a minus b whole square. Option D, a square minus b square. So, my dear students, look at, first of all, write the given equation here. X square minus of a plus b into x plus ab is equal to 0, right? Right. So simplify here, x square, right, multiply x inside here, minus ax, right, minus bx, right, left side ab come to right side here, minus ab, right. So here calculate this value. Calculate this value. So this can be written like this. So this can be look like a minus b whole square formula, right? So x square, right, plus a square minus 2ab means here 2ax plus this term also can be look like a minus b whole square, right? So x square plus b square minus 2bx, right? So this can be written like this here, students. X square, right? How many x squares are there? Two x squares, right? So 2x square, right? And also here minus 2ax minus 2bx, right, plus a square, right, plus b square, right. Up to now here 2 is the common, right? 2 is the common, right? So x square minus ax minus bx, right, plus a square plus b square. Up to now, right, up to now this can be written like this simply, students. Minus ab, right? So 2 into, right, minus ab plus a square plus b square. This can be written like this here, a square plus b square minus 2ab, right? So this expression can be look like a minus b whole square formula, right? This can be written like this, a minus b whole square. So option C is the right answer, students. Right. Okay, students, thank you so much for joining the session, for attending the session. Thank you so much and take care. Bye bye. Thank you.